good morning, afternoon, or evening, depending on where you are. My name is Praful from Corrosion Radar, and your host for CUI or Coffee, which is aimed at promoting online discussions within the asset integrity community to exchange experiences and ideas. I'm pleased to welcome our guest today, Stuart Bond from the Worldwide Corrosion Authority, NACE, and Mark Stone from ESR and the famous Hoist JIPs. Um, Good day to you both, and I'll let quickly introduce yourself. First, Stuart, over to you.
Thank you, Praful, and hello, everybody. My name is Stuart Bond. I'm currently with NACE International, but my background as a corrosion engineer goes back to 1987. I've been a professional member of NACE throughout that time. I've worked in consultancy, JIPs, failure investigations, etc., and moved to become a staff member of NACE in February last year, and thoroughly enjoying being on both sides of the fence.
Thank you, Stuart, and pleased to have you today here. Mark, over to you. A few words.
Thank you, Praful, and thanks for inviting me to be on the panel today. So I'm Mark Stone. I work with ESR Technology. I'm a mechanical engineer by background and have over 30 years experience, mainly in oil and gas, but with a focus on integrity engineering and trying really to leverage inspection applications to get better information to inform integrity decisions. And I've been involved with the Hoist Joint Industry Project pretty much over the last 20 years, developing recommended practices and so on.
Thank you, Mark. Stuart and Mark, thank you for joining us today. And, this community of CUI over coffee is rapidly expanding. And typically we have hundreds of attendees from over 60 companies, over 25 countries, which is fantastic to foster this discussion. So it is great to have this discussion today. The topic is a digital mindset. Are we focusing too much on new technologies or not? What are the opportunities? What are the trends we are seeing from your perspective, NACE and ESR and Hoist? And the people who are ultimately responsible for delivering the results, change and transformation. So this is an open debate, and we will also have audience interactions. So we'll get perspective from the audience as well. So this is how we will spend next 1 hour. We will aim to spend no longer than 40 minutes for the panel discussions, which is structured around 3 parts. And we will also have a few polls in between for the audience, give enough time of about 20 minutes in the end for question and answers. And the audience can post anytime the questions during the session using the tab at the bottom of the screen. And our intention is to keep the discussion at a high level in the beginning and then go deeper as we progress and during the question and answer sessions. So this session will be recorded and will be made available to all the registrants. We'll also aim to give mic to a few audience members in the end during the question answers. So if you would like to talk and share some perspective, you can indicate by clicking on the raised hand at the bottom of the screen and also post a question. So let's start. Has everybody got a coffee, hot drink, a masala tea, kava in Middle East, or mate in South America, and have a good coffee or a hot drink? So this brings me to the part 1 of the point about corrosion and insulation. It has been a major issue for the industry. It was identified probably 4 decades back as a major issue, and we are still talking about it. So from our perspective, there's a lot of talk about digital and the opportunities now we have on the corrosion management in general, and also probably CUI as a big use case of digitalization. I hear people talking about digital all the time for the past few years. So there's a sense of digital fatigue. In that sense, there are some successes, but there are some wasted resources as well. So if we go back into the past and learn from it, I'm sure there's plenty of cases where we moved successfully into digital ways of working, especially in corrosion management. So with that, I will launch the first poll for the audience to get a perspective about digital. So can we have the first poll, please, on the screen? So here we are. The first poll says, the question is, what does a digital mindset mean to you? So I'll request all the registrants and attendees to actually select the appropriate opinions and answers which they think. The second question is, which industry do you operate in? So this gives us perspective of which industry the attendees are, and that gives the context of the responses of the digital question. And where are your operations based? Regions, and that's also give us perspective which regions probably are thinking more on the digital and others. So while the audience will give a minute or so for the audience to respond to these questions, meanwhile, an opening remark. So Stuart, when we say digital, it's better to start from the past as to what were the problems we have been facing, and not only digital, but in general, what is the problem we are facing in the asset integrity and corrosion engineering. And then we'll come to the opportunities, but let's identify the problems and learning from the past as far as the asset integrity is concerned. So over to you, Stuart, for opening remarks.
Great, thank you, Praful. Well, I guess when considering sort of digital and digital technologies, I think they go hand in hand with corrosion. And a few examples I thought I could sort of put into this is the first use of hyperlinks I had was in 1990 on a knowledge-based, expert-based system. That's pre-internet. And that was to assist in corrosion knowledge and educating and using a system to better guide people in terms of that area. CRM, first one I used was in 1995, Telemagic. It's still on the web if you want to find the history of it, but it set the template for most of the systems that we use now. And that was great for working with colleagues, passing information together so we could work with our clients and engage with them in the corrosion sector. A few sort of specific examples. I was working on a problem that was global in copper corrosion in soft waters, and that required some in situ electrochemical testing to be undertaken. Main site was a hospital in Scotland. I was down in Oxford in England, so it's a good sort of 5-6 hours drive between the two. And this was back in the early 1990s, and to generate and collect our electrochemical digital data back then, you had a data logger on site, you had memory cards, you had to physically travel there to collect the information, get it onto the memory card, bring it back to base, parse that data then in those days to a DOS-based spreadsheet, and then work upon it. So all those different steps of transferring data, and of course, a number of times you find the memory cards actually failed, you had no data. So, the ability to be able to work remotely and interrogate and receive information would have been fantastic in support of that JLP on a major corrosion problem. Another scenario I was working on was a major issue in terms of consultancy. Was with one of the Condeep, Condeep gravity-based structures in the North Sea in the 1990s. These had the hollow concrete legs, which are no good under tension. And we had information to say that in their piping system, there was corrosion occurring. It was just visual observation, nothing more than that. And from that scenario, we had to understand how could we address this, because if the integrity of the whole platform could be lost with the water ingress into that system. So it was starting from first principles, what materials could be of construction, because there were 4 records, what were the range of different damage modes that could take place. So start from those first principles, we generated an approach which was to take us to what could be the worst case scenario, likely to be preferential weldment corrosion. And using the knowledge and expertise we had, we fed that into a system, worked with colleagues who were FEA specialists. So now we're taking this expert opinion and we're then converting it into a fantastic model, an FEA model of a joint where the corrosion was taking place, preferential attack. We went into great debate with the operators' SMEs over the issues here. And the key factor was, could the system still hold the load when a diver went down to clamp and repair that failed, or rather that leaking joint? And the key thing there was that once we put the data into a computer-based form, a wire mesh showing an FEA, you had to keep reminding people, where were the original data coming from? What were the accuracies in that? What were the assumptions behind that? And what was the confidence in the values that you were taking into that system? Now, thankfully, it was very successful. So we went down and we're safe, and we saved the situation there. But just a key thing to remember is that when we're taking data across, we've got to be absolutely confident in the source values and the variability that could have when we take that into the system and compare it. So, I think we just need to understand and ensure that, we take that on board when we're thinking about the digital system. it doesn't remove an expert's input. It doesn't necessarily remove the human input. It helps significantly, but we still need to make sure there is understanding of what we're starting with before we place it into systems of prediction and assessment.
So very well said, Stuart. I think machines cannot replace humans, but they can augment and help humans do their job better. And in this case, as you mentioned from your past experience, that corrosion engineers and asset integrity engineers can do their job better if we give them right tools, digital tools, as well as probably right data sets with enough information. So often the problem is about connectivity to the right amount of data. Say, if they are analyzing a particular failure scenario or assessing the conditions of an asset, how do you bring that data to the table of a corrosion engineer? And that's where probably one of the problems in the past have been. So that's great. Mark, what do you think about this aspect of the problems in the past and opportunities?
I mean, I think what Stuart mentions there about data and using that to support decisions is really key to a big part of digitalization. Obviously, it's not the whole picture. There's other aspects around automation and so on, but having access to that data and doing something with it and being able to analyze systems is really, really critical. And it kind of, the early part of my career I spent essentially between taking measurements in terms of, strain gauge measurements and so on, and also using that data to build finite element, let's say calibrate finite element models, build and calibrate finite element models that you then had a level of confidence in those models. But even just those processes are fundamentally facilitated by some form of digitalization. Certainly, 30 years ago, whatever, the kind of FE models that we were able to make were very limited, and pretty much like Stuart was saying, the kind of data you could get, like 64 kilobytes, for instance, in terms of a set of strain gauge data was a big data set in those days, whereas now 64 gigabytes is kind of something you can easily handle, and that's just going to expand in the future. But fundamentally, even at the simplest level, all of these things are reliant on some form of digitalization, and ultimately it depends on what you're going to do with that, because that data is only of value if you're going to use it to make better decisions, ultimately in the interests of improving business performance from an operator's perspective.
So thanks, Mark. I think you made a very punchy statement about, in the past, 64 kilobytes was huge, and now 64 gigabytes is available now. So it shows that there's a huge transition and computational power availability and also storage capacity of the data. The limitation is to be able to use that kind of information and use that kind of power. And as you mentioned, you had to go many times manual ways of collecting data into the field. But digital have been around from long, like you mentioned, finite element and methods have been there for analysis, but now they are at a much larger scale, but now they are also much faster as well. So how can the professionals in the field of asset integrity can use that kind of computation power and data science? So there's huge opportunity in corrosion management, as we all agree, and there has been huge challenges, especially from the access to the information, access to the data from the field to the desktop, and that's where the opportunities are. So let's look at the results of what our attendees are saying from this poll. Can we have the results of the poll, please, on the screen? All right, so let's look at that. What does a digital mindset mean to you? We asked this question. 44% of the attendees says connectivity to electronic data capture and integration into systems. I think this is about access to the data, so something we talked about. So 32% of the people say automate existing manual processes, and that's how they see a digital mindset. I think, again, part of the process. Interestingly, costs, bottom line, cost savings and streamlined processes, that's 0%. And that's a bit surprising to me that, it's not about costs when we talk about digital mindsets. It's about connectivity and automation, which is a very interesting aspect. The fourth answer is revenue. top line growth, faster innovation and decisions, so 24%. So this is revealing, right? I mean, people are not saying that digital mindset is about cost savings. It's about growth. It's about automation, connectivity, data access, etc. Let's also see where the audience is coming from. So our registrants are about 30% from upstream, offshore and onshore, 2% from midstream, LNG pipelines, 20% from refinery, and 12% from petrochemicals, and 37% from others like power industry, etc. So it's a kind of mix. And where are your operations based on? 15% from Asia Pacific, 61% from Europe and Russia, 10% from Middle East, and 15% from Americas, North and South. So we have a mix of audience here. I think it does not represent bias towards a particular geography, but in general. So Mark, I'll go ask this question to you. What do you think of this first question about digital mindset, what people have been saying? That it's not about cost, but about others.
I think obviously there's a big focus on connectivity and the automation was also an important part of that, which is kind of a key driver throughout the whole arena of digitalization. It is being able to do things faster, better, and I guess you tag on cheaper there as well as part of that. Being able to do more efficiently, and that's a big drive behind it. I mean, I think one of the useful things to look at when you're talking about digitalization and how it's transforming things is that, fundamentally the biggest gains aren't necessarily made from just doing the same thing as you've been doing historically and doing it faster and more efficiently, but there's a lot of opportunities around actually completely transforming how what you're actually doing and those processes, and that's where a lot of the gains around digitalization can be made. But that's also a big challenge, because fundamentally to achieve that, you've got to change processes within how organizations operate, and I'm sure we all appreciate that making that kind of change isn't always straightforward. So the technology can be there and available, and I think when you look at the sort of exponential growth and technology progress, if you like, over the last 20 years or more, increasingly these technologies are available, and the challenge is, well, how do you actually leverage those technologies within a sort of organization at an organizational level and practically implement it?
Right. I mean, thank you. I think it's a nice summary that one way to look at digitalization is to automate the manual processes, but which is faster, better decision making and analysis. But also the second point which you mentioned is one other way of looking at it is completely transform the way of doing things, and we'll come to that in the second part. But Stuart, what do you think of the reaction from the audience poll here?
Well, yes, I have to support what Mark has just said. I think clearly we are at a situation where we've been talking about digital technologies in various forms over time. I think some of the aspects of connectivity also relate to the ability now to have, for organizations which have global assets, you have the ability now to have a central engineering function where, much like horizontal drilling, 3D drilling and 4D seismic, you can have a sensor which is guiding a device that's somewhere else on the planet. And the data that we're collecting now, the ability to interrogate that, allows us to have experts working upon and supporting the local asset, but they're not having to travel around the planet to do so. They're able to bring their expertise to bear immediately and on multiple assets within their working week. I think there's some significant benefits there of leveraging perhaps your expertise to support those in the field. And also for those in the field to learn from that, and also to gain the supporting expertise in the implementation of the technologies alongside their skills and their specific disciplines. So, yeah.
Great. So I think it's a recognition from audience as well as us that of course digital have been around as a word in several industries, and we need to there are opportunities in corrosion management, asset integrity management, and we need to have mindset about it. That's the topic for today. Also, technologies are available, but how do we? Is there a mindset issue here? So this brings me to some more specifics. We'll move to the part 2 of the panel discussions, in which we will go slightly more details into what's in it for corrosion management in general, specific examples, etc. So before we do that, let's launch poll number 2 for our audience. And that's a specific question around what help is needed to unlock the digital ways of working. Now it's about mindset, but what is needed for the audience? How do they see it? Is it integration of sensors and wireless data logging, or is it predictive analytics? Is it standards and guidelines around digital tools for corrosion management, or change management and digital readiness of the organization, which is more of a culture of the organization which you're dealing with? So let's see what the audience is saying. But coming to our panel, Stuart, we have been talking about applications of corrosion management, digitalization in asset integrity and corrosion management. So are there specific examples you are seeing benefits of, or are there specific trends you're seeing from this perspective and your experience as a use case of this? It may be sensors, it may be data tools, etc. So what's your observations?
Okay. Well, I'm actually going to just jump in and use a non-corrosion example, which struck me is quite highly relevant here. That's actually in the field of NDT and phased array. And very quickly, typically on a pipeline onshore spread, you'd be welding joints and inspecting by radiography. That requires the expertise in terms of interpretation of radiographs. But irrespective of which equipment was used to take a radiograph, when an inspector could look at that and would come up to the same assessment of the indications present, irrespective of the system that was used. But I remember in one of the earlier days, there was a pipeline being installed, same welding procedure across the whole length, but in different spreads. So we're getting 50% reject rate in one compared to another. They went to investigate that. They were using 2 different digital phased array systems. When they looked at the procedures, they were being correctly implemented. It was just that the systems and the way they were configured were interpreting the resultant data being collected slightly differently, leading the inspectors to take a different view on the ramifications of the output in that system. From that, consequently, there was a lot of work undertaken globally, and now we have standards in place to assist in the way in which a digital phased array system is set up, how it works, and how it integrates. So people have confidence that system A, B, and C from different vendors will give them the same output. I think it was quite a nice example of something where we anticipated great benefits from having the digital system in place, but it actually led to some complications. But from that, you can see that as we move forward, I think one of the key things that stakeholders will be seeking is to ensure they have confidence that whichever system they believe is the best one for their assets is still going to give them data which the other systems would have provided to them. So I think that's one thing that comes to mind. The other thing is also that factor of incorporating the correct technical expertise. Because if you think about the offshore wind sector, when we went to monopiles, we were just driving those into the seabed. The application of cathodic protection seems simple. Take some software, it's a tubular structure, thrown into the mud, easy. Unfortunately, they didn't use corrosion engineers with cathodic protection expertise. They ran the software, they ran into problems because they weren't accounting for things like factors such as flow, scouring, etc. present there, and the different sort of muds they may be in. And so there were some complicated sort of rework problems arising. So it's still essential as we move forward with these capabilities, as we enhance the knowledge we have and the data can derive, we give all the stakeholders better understanding of their assets. We still recognize that there's still room and need, indeed, for human expertise into these systems. And I think that's one area where we can see now with robotics alongside digital capabilities for inspection. How do we now ensure that we've got the systems in place and that what they're deriving is sufficiently robust to fully act upon, and indeed in particular when we're trying to take that data and now move it into a predictive sense. And so here I think we've got room for both the expertise for the corrosion engineer in combination with the practitioners who are actually out there assessing and doing the in-field support of deployed systems. So I think there's definitely positive aspects here we can build upon.
So I think it's a nice interpretation that the first example you gave about phased array ultrasonics, you talked about subjectivity of, I think repeatability and reproducibility of the data collection itself. and can digital advancements help in that? For example, say if we log the exact procedures which have been used and probably store it in the right way. Uh, uh, so kind of trying to remove the subjectivity and tackle the reproducibility and repeatability of the measurement itself through better data management, and the procedures. The second point is about the skills, which so for example, how can we have the right skills to remove the subjectivity from the experts and help them actually make judgments rather than the routine data analysis. And some of the corrosion engineers, if they have to go to the field, it's a long effort for them to go to field, collect the data and come back. But if they rather focus on the decisions and judgments rather than data collection, that will improve a whole lot. In case of, say, offshore structures like wind monopiles, that's pretty much a big deal there. And so these are specific examples where digital developments can help. Mark, what do you think on what are the specific examples of what we have seen and what we are seeing in
I think what Stuart mentioned about the understanding and guidelines needed to create some sort of standardization so people know what they're actually getting. That is a really critical part of it, and obviously there's a lot of organizations working towards that, but in some extent it's sort of still lagging behind what industry really needs. So part of the work in HOIS, for instance, is trying to address some level of standardization. Increasingly that's being driven towards digital related topics, and there are other joint industry projects about robotics, for instance, that are trying to address similar kind of issues. And I think a key part of that is also validation. When new technologies are coming along, from an end user perspective, in order to understand what they're getting, validation of that is really important. And having processes to validate these systems is, again, in many respects, is kind of in its infancy. And I think even relevant to, I guess, increasingly what we'll be seeing in terms of predictive analytics and approaches, analyzing data, where machine learning is going to play a role. For instance, there's big questions around, well, how do you validate a process that you can't fully understand? Because of the nature of machine learning, it's not a deterministic methodology as such. So how do you validate machine learning is going to become these expert systems.
Right. So
that's where the role for the human expert remains very, very relevant, I think.
I think it's a nice point here that it augments what Stuart had been saying, that digital can help us in repeatability and reproducibility of data collection. Let's move the efforts towards more analysis and judgment, as you all also have been saying, using machine learning, using computations, using tools. But let's remove the subjectivity and rather the corrosion engineers, asset integrity engineers should move to more high value activities like making decisions. So that's interesting, and data science can help a lot in that, as you have been saying, Mark, that machine learning or advanced statistics even. So
I think the other part of that is the knowledge and kind of background, I suppose, of the people involved, where historically when you look at sort of integrity, corrosion and inspection functions, it's been the kind of remit of the integrity engineer, the inspection engineer and the corrosion engineer. Whereas as we kind of the world changes with introducing a lot of new methods around data science per se, and even moving towards machine learning, the nature of the sort of core integrity teams is also going to need to adapt, and that that in itself is kind of, if you really want to leverage these new technologies, that's going to become pretty much fundamental to achieving that.
Sure, I think skills are very important here, and we'll talk about skills in the next part. Let's see what the audience is saying about what help is needed to unlock the digital ways of working. Can you have the results, please? Okay, so it's a kind of mixed feeling here. quarter of the audience says integration of sensors and wireless data or logging. 28% of the people are saying predictive data analytics. 16% of the people are saying standard and guidelines around digital ways. And interestingly, the majority, 33%, are saying it's an issue with change management and digital readiness. And the organizations have faced some kind of inertia towards that. Maybe people, maybe the culture, maybe priorities. But it's interesting that it's a mixed package with that, and it's a system issue. It's not only one issue to move to digital, but it's a whole lot of other aspects to it, including change management and digital readiness of the company. So can we have a bit of analysis of this? Mark, what do you think of this particular poll?
Yeah, I mean, it's interesting that they are kind of distributed across all these different areas. Obviously, they're all important, and different people will have different kind of priorities. But I think the one that's really interesting is around the fact that the change management and digital readiness kind of wins by a short margin, but it's still considered the most important. And
so Mark, do you see that as a big issue when you practice and talk to the end users of digital ways of doing it in terms of the data science or visualization? The change management is an issue, the digital readiness of the organizations?
I think it's probably an underappreciated issue in many organizations. I mean, the focus of a lot of that has actually been on the developers and suppliers of technology. When you think about technology readiness levels and so on, and even sort of business readiness levels are focused on the organization that's going to be supplying the technology. I think what's missing still is something around how that's managed within the end user, because that's where ultimately the biggest transformation in order to leverage these things needs to happen, and it's sometimes the most difficult, because of the complexity of the different elements of the organization is where it may be more difficult to actually make happen. So when we talk about change management and digital readiness, I think it's important to extend that beyond just thinking about the technology providers, but also, fundamentally for the technology user at the end of the day, to be able to take that on board. That's where a lot of this needs to be considered.
Thank you. Stuart, your quick comments on the reaction from the audience here.
Yes, well, I think I'd support what Mark's saying here, that principally here what we've got to look at is all stakeholders. We've got to find the right way in which we can engage at the different levels and in the language that those different recipients need, so they can recognise the benefits derived from the approach. I know with the NACE Impact Plus study, we derived from that a system to allow companies to look at their corrosion management systems and basically rank themselves against best in class. And that was designed to communicate corrosion management in the terms that the C-suite could understand, putting it in terms of cost benefits, putting in there as to why are we imposing this cost on the organization, what's the benefit to the organization. And I think that's the challenge we have here with these technologies, is to take us from a technical field where we've got technical experts on one side in terms of digital data interpretation, assessment. We've got the corrosion expertise, etc. there. We can talk in great depth about what we're doing. But to implement it, to manage that change, we then need to roll that out in a way that's received well by the asset owners and also brings people on board. Because I think we have to recognise that there can be concerns about job security and future career paths when you're rolling something out like this. And I think that's part of this change management we need to put in place, so the two are seen hand in hand. And it actually enhances someone's role and their chance for progression. It doesn't necessarily eliminate it.
Right. I mean, it's also about, say, as we said, change management, upskilling people. They seeing digital as an opportunity, not a threat. I think that's one of the key points here. But so let's move to the third point and the third part of our panel. At the beginning, we'll launch a poll of that. So can we launch another poll, the third poll for that, which talks about what new and improved digital skills are required for corrosion inspection and integrity practitioners? Is it modeling and simulations? Is it data interpretation and analytics? Is it systems design and implementation, say IT and automation? Or the fourth one is business case development and change management. What kind of skills are needed? I'm sure all of them, but but what is the priority? Let's see what people say. So this brings to us to a specific examples. Now we talked about high level. There are opportunities in digital ways of doing for corrosion management, for integrity management. The first part is about data access, basically data logging and data access, inspection reports being formalized in shape or form, and people should be able to access them very quickly. That's very crucial. The second crucial point is repeatability and reproducibility of the data using automation tools like robotics, and also probably data management, and also we talked about using data science to greater extent, because now we have the computational power and storage facilities to store huge amounts of data. But how can we use for our benefits kind of data analysis tools, say automated tools? That's what we discussed, but let's take a specific use case of CUI. What are the opportunities for digital in CUI? Is it about inspection management? Is it about data logging, sensors, or is it about visualization, data science? There are many angles, but often I hear that CUI is among the biggest use cases of digitalization because of huge amount of manual efforts which are being put on CUI management, which can be automated through some shape or form. Let's talk about that a bit. Stuart, what do you think about this? What is your observation about all these trends about CUI and applications of digital tools in CUI?
Well, I think the developments in CUI and digitalization are very exciting, and in particular now the amount of permanently installed systems which are being developed and put into the field. It really does enhance the knowledge of an asset's current state and condition, and allows prediction, I should say, of a likely future state. And I hope that through this focus on what is a major problem for industry, it will actually enhance the rollout of these technologies into other damage modes. But I think we still need a few things we need to consider here in terms of challenges that we face. When we're looking at the corrosion assessment and prediction, that area I think is a challenge, and I reflect on the fact that as a corrosion engineer, if asked, will the asset last 25 years, I say come back in 25 years. Let's see what it does in situ. Clearly, you can't do that, and you're asked to actually set up testing. And what do you do when you do testing? What you do is you take parameters and you change them to accelerate that test. And the more you change, the further you take it from its natural state, the more you've perturbed it from that state, the further you move to something that eventually ends up as simply a ranking test in a lab, ranking A versus B versus C, for which actually predicting life is very, very difficult. And I think where we are now is a situation where I think these systems being in field, we have a great chance to get an iterative loop. So we've got our current understanding and predictions of what should happen there based on our knowledge. But I think these are now presenting great opportunities where taking that data and then looking at how our lab tests would have predicted performance, modifying those tests so they more accurately do predict that performance going forward. I think there's a great opportunity here, because then that leads itself naturally to how we then would look at developing and enhancing test methods for coating systems, insulation systems, etc., so that we have confidence that the tests really are representative and are deriving data that's valuable at that point of selection. And it also then gives us confidence that the systems we're deploying for their predictive state thereon after for the inspection, and the data we derive from that will really give us a true prediction of what happens. Now, saying that, of course, we're currently mainly looking at CUI in the context of carbon steels. So here, I think we've got great advancements taking place. I think there's still room for the industry to work with the coatings manufacturers, to work with those who are developing smart coatings themselves and integrate with those, but also with embedded sensors within the coating to determine the actual condition and state of the coating. Because we have a system here, we have a system of the substrate, coating system, and insulation, all of which manifestly bear upon the likelihood and then subsequent rate of degradation that will take place. And then I think your next challenge after that is with corrosion-resistant alloys. In these cases where we've got highly localized damage mechanisms, crevice corrosion, pitting corrosion, they've always been a challenge. I know even in the lab, trying to create chloride-induced stress corrosion cracking in some alloys, it actually was very difficult to create it in the lab. I see Mark smiling on the screen. You can't see him, but yes, there have been cases where you think I can make this crack easily. I've got all the parameters correct, but I can't get the crack in the lab. And then how does that allow you to set up testing to check if the system now is viable in terms of deployment to pick up those forms of damage going into the field? So I think you've got a great starting point here. I think it sets the scene for how these systems can be deployed for other damage mechanisms. And I look forward to seeing the way you address the CRAs as you move forward.
All right. So I think it's a great point that, for CUI specifically, the issues have been validation of systems from laboratory to the field, and the feedback loop has been missing. And can digital automation tools can faster that progress, because ultimately we have to prove the systems in laboratories like coatings and installations and sensors and move to the field, but many times they fail in the field, right? Or give different results. So can we make this loop faster? That's one of the opportunities, as well as you mentioned about prediction being an opportunity for digitalization of CUI. Well, it's a hard problem. I'll move to Mark. Mark, what your comments are on this thought process about opportunity?
Yeah, I mean, I think that the prediction end of it is really critical, and building a better understanding of how the mechanisms are going to evolve is really crucial. To try and ultimately, I guess you want to try and limit that as far as possible, but there's still a big role for inspection and monitoring, and that's really aimed at understanding what you've actually got in the field and trying to being able to take action based on information you get from that inspection to prevent failures. But that's really where there's a lot of potential around digitalization, particularly when you look at, it's not a database thing, but if you look at sort of 3D models and so on for helping plan better inspections, even visualization associated with that to help you understand where there's more likely to be CUI, for instance, looking at the condition of the cladding. And there's a lot of efficiencies that can be gained from these sort of visualization systems, which are starting to play a bigger role. So from purely from a deployment side and planning, logistics of inspection and so on, there's a huge role, which isn't sort of directly related to the data that you're getting at the end of the day. But that data that you're getting is also a key part of it, and I think historically a lot of data related to not just CUI, but CUI is one example of where companies have a lot of data around failures and problems that they've had in the past and haven't really leveraged that information. And there's a role for making better use of legacy data in order to be able to better understand, build better predictive models ultimately, and better prioritize your inspection and maintenance activity.
Right. So I think it's evident that prediction is a big use case of digitalization for CUI management. Even data visualization as well can cut short the cycles of interpretation, and that's a great point here. And use of historical data for assisting in the prediction models. Of course, we have a lot of computations, a lot of data, and a lot of data is not being used for making those predictions. So we can use historical data and we can use future data using sensors and automation to from now on have a structured amount of data being logged and use that in an automated fashion for prediction. But prediction is a big use case of CUI. So that's a great output. Let's look at what audience is saying about digital skills which they need for efficient digital corrosion inspection. So 3% of the audience is saying modeling and simulation is probably this coming from practitioners in the field, that modeling and simulation is only 3%. Data interpretation and analytics, it's 50%. That's where the skills are needed. That's what they're saying, half of them. 28% is saying digital systems designs and implementation like automation tools and IT systems. Those kind of skills is 30%. And about 20%, 19% of the people are saying business case development and change management. I think all of them are balanced, but modeling and simulations is getting the least part, and that's where machine learning, etc., which goes to the specialists. So this is coming to that. So I think we are. This is high time. I think we are slightly delayed for question and answers. Let's move on to that, and I will request the audience members to post their questions. We have some questions coming in already. We will start with those, and I'll encourage the audience to just keep posting. And if you are interested, raise your hands. We'll give mic to a few people. So we will be brief in our answers to tackle as many questions as possible. The first question, which is, so how can we capture the cost benefit from digitalizing inspection process for corrosion management? So that's the first question, cost benefit analysis for inspection processes. My perspective is, I think there are two angles of cost benefit analysis. It is the cost and the safety. So can we reduce the cost and increase the safety? Now, the two judgments here. Increasing the safety in terms of increasing the repeatability and reproducibility and trustworthiness of the measurements, but reducing the cost in terms of, can we do the inspections only when it is required? So moving from condition-based, so periodic inspections to condition-based inspection only when it is required, and where it is required. So narrowing down the zone of risks to where the inspection is required. From my perspective, those are the two angles of cost reductions as well as increasing the safety. Mark, what do you think on this aspect about cost?
Yeah, I mean, I think it is critical, obviously, to supporting good decision making. I think when it comes to the cost benefit, like you say, there's the cost of actually doing the inspection, and that's going to vary according to the kind of activity that you carry out. But equally, the capability and performance of that inspection in terms of what level of information it provides you is linked to fundamentally to the cost of that inspection as determined by its strategy. So it's trying to find an appropriate strategy that gives you the appropriate level of risk mitigation for the system that you're working at. And part of that is actually understanding the performance of that inspection strategy, and that comes back to a good understanding of the corrosion mechanism with CUI, like being able to target particular locations, but then equally what techniques you're going to be using. And there's obviously increasingly an interest in using NDT techniques as opposed to sort of traditional strip and visual approaches. But obviously those techniques have varying capability, and I think it's fair to say none of which equals the capability of strip and visual. So actually being able to quantify the performance of those techniques is the starting point in developing strategies that you can actually run a realistic or representative cost benefit analysis on.
Right, thanks. Next question is also very interesting. Is by using digital solutions, can I decrease my coating and insulation costs for my CUI management program? And that's a very interesting perspective. Normally coatings and insulations are necessary, but can digital solutions help in reducing that cost? How do you respond? So Stuart, what do you think? How do you respond? And then we'll come to Mark.
Well, it's an interesting one, Praful, in terms of decreasing the costs. I guess one's considering whether it's CapEx that you're reducing or OpEx in this regard, because
I think this is a CapEx, yeah.
Yeah, it may well indicate that at the time of build, actually, from the information you have of similar assets, perhaps in a similar geographic location, you actually need to spend a little bit more on your system than you would have desired to do, because information you have from other assets now is indicating that you actually need something with slightly better performance. So taking that information across a location geographically, I think there's benefit to businesses there to actually perhaps even share some of their information. Some people in the corrosion world will recall we used to try to do these corrosion maps of the world and look at corrosivity in different locations. We always struggled to do that. We had a few panels exposed in different locations, time of wetness measurements and things of this nature. I think as you look at assets now, having these systems deployed, then you can take from that more information that not only looks at what the asset conditions is, but also then what corrosion conditions are being generated there, which are specific to the plant, which are more general to that local geographic region. And that feeds then into modification or expansion, new build that you would undertake. And that would help you to look at your insulation system and your coating system that you might deploy. And as we said before, coatings manufacturers now are making smart systems for their coatings. There's a potential to embed sensors. So there may be an initial higher cost in CapEx, But when you look at the benefit that's derived from your OPEX costs being reduced significantly and achieving life as desired, then I think that's where we turn this thing back around to the cost benefit approach, is to, how are we deriving maximum benefit and ensuring we translate that into a system that and communication that is understood by the project team at first feed and detailed design stage.
Yeah, I think it's a good point that if we have a map globally about corrosion rates acquired through some database and through sensors or past results, we will be in a better position to judge where we can reduce the cost of coatings in which geographies, because you can't apply the same principles which are used in, say, tropical region to, say, very cold regions like northern hemisphere. Because the corrosion rates may be very different. Coatings maybe in some places in arid dry climates it may not be required at all, or some other forms of insulation may be needed if very expensive insulations are not needed. Why to use them? And that can be coming from the map of corrosion aspects and database from the CUI, how different systems respond. So I think that's a great point. That's the other question which is coming in is again similar question as to what are the most common issues that hinder the applications of digitalization in corrosion management. And I think I'll start with Mark on this. What are the common issues that hinder applications of digitalization in corrosion management?
I think
you have been doing a lot of work on that, but where do you see hindrance?
Yeah, I think it's helping organizations make the change to using more of the technology that's available, and that's a multifaceted kind of thing. I mean, one of the sort of cornerstones to that is having validation of the technology. So having the technology available is one thing, but developing an understanding of how reliable that technology is, how you use the data from the system is also key to it. But then the other side of it is on the sort of internal end user processes, making changes to those processes to be able to take on different forms of data and information and changing those practices. And I think, within large organizations which maybe, have operations all over the world, making those changes is difficult, and spreading those changes across the organization is difficult. So fundamentally, being able to speed up some of that change will help companies take on board these methods.
I think it brings back to the point that it's not about the technologies are getting available, because some of the other industries have been progressing much faster.
Well, I think part of that is actually validating that technology that is available. Yes, the technology is, 100% agree that it's out there. There's a huge sort of array of technology that's advancing really rapidly, but a lot of it does need validation and sort of
change management. Yeah, change management and probably validation. Change management is a huge deal, because that's where the organization needs to change the culture of the organization, tackling the threats and opportunities of the employees' mindsets, and also validation of the technology, as you mentioned. Trust in the developments. How can they trust for longer? So we'll take one last question before wrapping up the session with final thoughts. The last question we'll take is it's a very apt question. What NACE and HOIS are doing to promote digitalization? And I wanted to ask this question myself. So, going to Stuart, what NACE is doing to promote digitalization? And then I'll ask Mark. Stuart?
Thank you, Praful. Well, I'm very pleased to say that Praful is one of two speakers who will be presenting on a webinar on this very topic on the 7th of July. So that's an online event that we should get information out on to LinkedIn, etc. very shortly. We also have our European Corrosion Management event that will be a virtual conference in November this year, where we are addressing this amongst topics on corrosion management. And we've also been running what we call our corrosion technical series, looking at key issues, the leading edge issues which are coming from adjacent industries and disciplines bearing on the world of corrosion. So we've looked at things like robotics, we're looking at MIC, for example, but we're also looking at digitalization in that context as well. So basically there are active things underway. A lot of these now are going to be accessible online, so you can gain sort of access to experts, engage with them, and hear the latest activities directly from us. So that's where we are currently. We've got CUI, of course, training program that exists already, and those programs change as things mature and move forward. And I guess, when we look at the aspects of training personnel and indeed certifying personnel, they need a relatively stable state in which we can bring this on. So I think digitalization will go into that training at a point where we are all confident it's a stable maturity that we can bring that through. But more than happy if people have got questions about what we're doing at NACE, just contact me, no problem at all.
That's great. I think it's great to see. My takeaway from that answer is NACE is doing a lot of efforts on digitalization education through webinars, through online channels and training courses. And they are engaging with companies like Corrosion Radar as well, to promote digitalization, trying to bring and educate on the best practices and benefits. And that's great to see the developments on that side. So, that's evident that, NACE is taking digitalization education. Going to Mark, what Hoist is doing about digitalization and corrosion management? Any specific initiatives?
Yeah, I think firstly on CUI specifically within Hoist, there's been an active program around assessment and validation of inspection technologies, NDT technologies for CUI that's been running for quite a number of years, and that's more recently has had support from the Oil and Gas Technology Centre in Aberdeen. So that's really trying to give the industry an understanding of the quantified understanding of the capability of the different options when it comes to NDT for CUI. And then, more broadly than that, there's a program in Hoist currently on digitalization, which is really focused on digitalization as with regards to inspection and kind of related integrity applications. So that's looking at things like use of mini digital twins, basically as a means of using inspection data better, and also looking at the data processes. How do you, what data do you need to manage throughout the process in order to make better use of digitalization? And that program's got input, and there's working groups, and also recently there've been a number of online forums, so far restricted to Hoist members, but typically those would be a few hours where there's input from several different speakers. And that program, Prafil was involved in one of the recent ones, but that program is going to continue sort of every 3 or 4 weeks going into the future, trying to explore different applications of digitalization.
Again, coming the same point here, that Hoist have been active in digitalization as the next frontier of corrosion management through JIPs. And ESR have been promoting digital corrosion management as well. So, and Corrosion Radar is very happy to be participating in the digitalization of the GIPs. And I'm sure there'll be bigger GIPs coming in the future where multiple large corporate oil gas companies will be participating in that digitalization GIPs to standardize some of the processes. And we're happy. From Corrosion Radar perspective, we are happy to participate in both all the initiatives and contribute to that. In fact, that's what Corrosion Radar is all about. Talking about us, we see corrosion as a huge opportunity, corrosion management as a huge opportunity to reduce the cost and increase the safety through digital means, through sensors, IoT, and digital analytics tools. CUI has been a major use case for that, and we are seeing a lot of successes globally on CUI being managed in a more efficient way, in a safer way, reducing the cost, using sensors and predictive analytics. And that's what we are doing. So we're happy to be interacting and working together with NACE and Hoist on that. So with that, I think it brings to the end of our session. It's been a great session, and thanks Mark, thanks Stuart for coming on board and sharing your perspective. Again, the outline and summary, I think, is there are huge opportunities in terms of corrosion management and digitalization, making the asset integrity professional more efficient by moving their activities towards expert judgments rather than data collection and manual ways of doing it. So huge opportunities, and they may lie in sensors, they may lie in data collection, they may lie in IT systems. For that, we need digital skills especially in data analytics. So I think the future of corrosion management is data analytics. Leave the data collection to automated systems. So I think that's where we have to get into. So thanks all the audience. I would like to make a specific comment that next bi-weekly CUI or Coffee will be our grand finale, where we will have Corrosion Radar specifically talking about CUI monitoring of the systems, and we will have some end users of the CUI monitoring systems being talking about it before we go into summer break. That will be a great break to CUI or Coffee. So looking forward to all the attendees to join that next session. With that, I think please do like our LinkedIn page where we announce events, and also key announcements are made there on the LinkedIn. Follow Corrosion Radar page, and if you have any questions, please do send an email to webinars@corrosionradar.com. We'll be happy to share it with our panelists and then go back. There are so many questions today which have been unanswered. We'll share it with our panelists and get back to you again. So stay tuned for the next grand finale after 2 weeks. Again, look for the announcements on the LinkedIn. And till that time, enjoy your coffee at your places. Thank you, Mark. Thank you, Stuart, for joining us today, and thanks all the audience. We will send the video recording within 24 hours, and stay tuned. Thank you.
Thanks, everyone.
Thank you very much.
Thank you very much.
Bye.
Bye-bye.